Hi everyone, welcome back to the channel. So this is the continuation part of the NQT exam preparation for the coding preparation. So let's get started. So the first question for today. Okay, the Bob is going to be bet today on a horse riding. Okay, there are n horses listed in a sequence of 1 to n. The probability of winning of each horse is different, so the prices of making a bet on horses are not the same. Okay, there's no limit on number of horses on which he can bet. Okay, no limit, but he thinks that if he bets on a continuous sequence of horses that he has a better chance to win. Bob will get k units of money if any horse on which he bets will win, but as the award is only k units, so he wants to put money less than k. Of course, if you're getting 100 rupees on a bet, you would definitely want to go with 90 only, because if you're keeping, like, if you're spending 150 and you're winning 100, that's a loss for you. So of course it's a normal. uh, they also explicitly mention that the Bob wants to keep the money less than k. Okay, the Bob wants to bet on as many horses as you can. So as you are his best friend, he reached out to you for help. Can you please find the length of the maximum content sequence of horses on which Bob can make a bet? And remember, he will invest money less than k units. Yes. If there are more than one possible combination, Bob will bet randomly on any one of them. Okay. Given the number of horses n, reward money k, the prices of betting n horses. Okay. Um, so we have n equal 10. That means 10 horses are there, and the sequence of buying, or sorry, betting a horse is this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So these are the sequence. So we have to find the sequence, or the maximum sequence, the maximum number of horses that he can bet, and that will give a more probability for Bob to win. So for example, so now we know that 100 is the profit. I mean 100 is the k value. So when 100 is value of k is 100, then if we check the array here, then we have to find a sequence, a continuous sequence, that should be, the sum should be less than 100 only. So if you take this 30, 40, 70, and if you add this 50 again, 120. So even these three sequence is going above 100, so we cannot take, but we can take only these two sequence. So 30, 40 is one sequence. Okay, again 40, 40, 50 we can take 40 and 50. We have two more sequences. 40, 50 are done. Then we can start with 50, 50, 20 we can take, 50, 20, 20 also we can take, but we cannot take 50, 20, 10, it will be 100. So we can take 50, 20, 20. Okay, cool. So 50, 20, 20, which is 90, this we can take. And next we can take 20, 20, 10. So this is again one more sequence: 20, 20, 10. Then 20, 10, 90 we cannot take, but we can only take 20 and 10, 20 and 10. And 10 and 90 we cannot take, 90 and 10 we cannot take. We can take 10, 10, 10, 10. So it will be 10. So out of all this combination, the maximum number of horses he can bet in order to win, the probability, I mean the probability of him win, the Bob winning will be equal to 3. Because if you see, if he chooses this or this, any of these options, the probability of, like, if he chooses one of any of these two options, right, like 30, 40 or 40, means he is only betting on two horses randomly if you're choosing only two horses. But if he's betting on maximum 3, the probability of winning Bob is increasing. So that's why the maximum probability that can be possible is the set of 3. So output will be 3. Like this way we have to find out what will be the output for this code. So okay, maybe let's quickly write an pseudo algorithm for it. For the first question, okay, we have n, we have k, and we have maybe horses. Okay, so what we have to do, we have to run a loop, maybe a for loop, which will go from index 0 to n. Okay, and these should iterate and calculate the sum value, sum of sequential horses. This should get incremented, or I would say added to the value of that particular horse. Maybe let's suppose if we take for some variable I, then we can take horse of I. So we have to keep on adding it and make sure that this sum is less than k, else you have to break the loop. If it's less than k, you have to find the maximum number of horses. Okay, and we can store in some maybe max horses bet, some variable. Then at the end of this pseudocode, we can be sure that this variable will have the max number of corn that Bob will be betting on. Okay, so yeah, so this we have to code. Let's try to code this in Python first. Yeah, so this is horse betting. We have discussed some n value 10, k equal to 100, and horses betting price list is equal to, where is that, yeah, 30, 40, 50, 20, 20, 30, 40, 50, 20, 20, 10, 90, 10, 10, 10. Okay, we have the data ready. Now as per the pseudocode, let's initialize the for loop for I in range of n. You have to have some starting, and maybe we can get sum of sequential bet. Okay, let's keep this as 0. As we have to calculate the sequence, so we have to do the sum here, right? In order to do the sum, we have to again initialize the internal for loop as well, as we have discussed here. Even if you see, we started with 30, we checked 40, we checked 50, like that. We again started with 40, we'll check 50, 20, 20, like that. From one index we will be going to another index, maybe j. So let's write the internal for loop as well. For the j in range of, this will be from I to n. Once we have the sum, then yep, so horse bet will be of j. Then we'll do the condition if sum is less than k, then let's declare maybe a variable called max sequence count 0. So max sequence count equal to max of max sequence count, comma, we can write I minus j plus 1 if you see, because if you take the position as 0, maybe I'll take a random, yeah, this example 50, 20, 20. So 0, 1, 2, 2 is the value. I guess 2, oh yeah, j minus I plus 1, sorry. Then 0, 1, 2, 3, 4, 4 minus 2 is 2, 2 plus 1 is 3, so that we'll get the value 3. So by just finding the difference between the I and j, we can get the exact count of the sequence, and we have kept it in the max, so it will compare the previous max count. For the initial it will take 0, for the next element whatever the max count has been stored in this, that will be compared to another, because here for the first iteration it assumes 2 is the max, next also it assumes 2 is the max, then when 3 came, it updates it to the 3, and it will just try to traverse the next sequence of elements, else we'll just break it. Okay, so once we have this, let's print max sequence count. Oh, maybe I'll just maximize this. Yeah, so this is the code. Let me run it. Yep, we got 3 as the output, you can see below. So this is how we can. Now this the problem here is we are using one loop, another loop, it's also going till n, so the time completely here becoming completely 2 loops, so order of n square. Now let's try to reduce this time complexity to order of n, because we want all the test cases to get passed, right? So let's try that. Okay, so this remains same. What we can do, we are staying at one horse and we are just trying to compare and increase the sequence, right? And this concept, just ignore the horses. You can see this index we are keeping pointer 1, and then we are going to next pointer, again we are keeping here going to next pointer. And this kind of problems are we can solve using sliding window, correct? And this sliding window is very important, because I guess in this NQT preparation itself, this is the second problem we are discussing about sliding window. And if you have not checked the video, just check the video and also search about sliding window problems and try to solve as many as possible. It will not just help in the NQT, even on the other exams as well. That's a homework for today. Okay, so yeah, sliding window, right? So it's the same the way we have executed here, right? So what we did, we checked 30 as the first, so this becomes, let's say, a start, so the start pointer. So this will compare with the next element. Okay, then we'll compare with the next element, this is greater, then we'll end it here. Okay, then this became a one combination, and again we'll start from here, we'll go here, like that we'll be putting all the combination the same way that we have understood the problem, and at the end we'll just pull it. But the the current log algorithm that we have wrote, we are like explicitly using a for loops, which will go from 1 to n. Again it will start from I to n, which is almost like going from j minus I to the n. So it's like n number of times into n number of times, so n squared times we are iterating. That's why order of n square is the previous time complexity. Let's try to reduce this. Okay, so this remains the same sum. Instead of for j, what we can do is we can write an while loop to check this condition. If sum is less than k or sum is greater than equal, whenever sum is getting increased, we will shift this start pointer to +1. You see that after 40 the sum got increased, so we went to 40. The same logic we'll implement here. So what is the change here? We'll introduce a while loop, check the condition that it should not exceed the k, and next the second condition, whenever it exceeds the k, we'll make sure to increase the start pointer that we have discussed. Now once we have the start pointer increased, then the end pointer will be always maybe start and end, we'll keep it here, the 2 pointers, and based on how the traverse is going, we'll keep on moving the end pointer and start pointer. And the end, this anyway the same logic, start minus end plus 1 will give the exact count. And when we are traversing further, the difference between, the maximum difference between both and the previous maximum will give us the solution. Okay, so yeah, maybe we can code it. What all changes we discussed, we'll replace this with a while loop, right? While we'll keep like greater than equal to, if it's greater than equal to k, and at the initial time itself we'll make this as opposite of I. We discussed about start and end, let's keep this as end. Then maybe we'll declare here start equal to 0, end equal end equal to 0. And what else we need? Okay, maybe we'll start from here. Then yeah, this sum of sequential betting price, this is also 0. Okay, initially 0, we'll keep on adding, and when the sum becomes greater than k, then we'll remove that. Okay, cool. Once we remove that, sorry, we declared end, right? So we have to increase the start plus equal to 1. Okay, because if you see, the moment we touched 50, we know that it exceeded, so we have to go back. So that's why we remove 50 from the sum, and we keep the start pointer. Start pointer was previously at 30. We'll make sure it will go to the 40. That's why start equal to start plus 1. Okay, now we have this, and we don't need this. Max sequence count equal to max sequence count comma j minus, here it will be start minus end plus 1. Okay, there is no break because while will take care of it. So everything seems correct. Let's try to execute. If any issues, we'll debug. Yep, we got the issue. So where did we miss something? Start minus end plus 1. Yeah, so what we did, we added end here, which is correct. We have to remove the start because we have to remove the first element. Then it will be end minus start plus 1 here, because we will be removing the first element 30, and we'll be continuing with the other the next preceding the next continuous elements here, or sorry, the next horses, the betting price. So if we try executing this, it is 3. Okay, yeah, so this is how we can solve. But you might get a doubt here as well, like this is a for loop, Ajay, cool, and this is also a while loop. So how can both loops cannot be an n square? If you see, the while loop is only getting executed at most 2 times here. What is that? When the start, when we have the price greater than k, or when we want to increase the start. Apart from this, there are no other what you call ways or probability or chance where the while is getting executed. So mostly it will be executed 2, so it will be 2 into n, which is 2n in the order. If you 2, it will be order of n only, not n square. Okay, yeah, so that would be for the first question. Let's go to the next question. You have a storeroom in your house. The storeroom is at square type and has sides of length n. Your mom has divided the room into 2-dimensional matrix M. In each cell of that matrix, there is a box as weight W of J. Okay, so let's understand. Maybe if it's like a length of 4, then this is the storeroom, and 1 2 3 4 1 2 3 4. Okay, it's a square type, so it will be on the same. So this will be M size, and this is every matrix. This index has a weight which is W of I comma J. Okay, as you're a mathematician, you are very much interested in the median concept. Okay, so your mom gave you a task to test your intelligence. You have to find the minimum of all row medians, okay, as maximum possible rearranging the 2-dimensional column. Okay, you are accepting only if the sum of medians and rows should not exceed the tolerance. Okay, so we have like 3 takeaways here. First, you have to find the minimum of all rows, then it should be the maximum of possible rearrangement, and also we have to make sure it's not exceeding tolerance. So let's understand the question. What is the to do here is, you have to find, the first task is to find the row medians. Okay, in this row, what is the minimum of the minimum row medians? So this is the row, first row, second row, third row, fourth row. From all this, what is the median, minimum of all the median? So like if there is 1 2 3 4, and if 3 is the median here, and 2 is the median in the next row, and 1 is the median in the other row, and 4 is the other one, so the least is 1. So we have to pick the minimum of all rows. So from all the rows we have picked, 1 is the the minimum medium. And here from that we have to do the maximum possible by rearranging two-dimensional matrix. So this is one way of arranging. We have like suppose n elements here, uh, which is like n is the size here, so the n square elements are there. Then this n square you have to rearrange, so one can be here, one can be here, one can be here, four can be here. So basically they want us to do a permutation. Okay, so in using the permutation we have to rearrange and we have to find all the arrangements. In all the arrangements we have to find the minimum number, and from all those minimum numbers you have to find the maximum. Like, you got it. First take a matrix. Okay, for the n square, list out all the arrangements with the permutations. Then once we have that, for each matrix find the medium. That should be the minimum. Once we have minimum of first arrangement, minimum of second arrangement, third, fourth, we have all the arrangements. Then with combine all the arrangements, all arrangements minimum medium, from this all big list, try to pick up the maximum possible element. Also, this minimum that you have to that pick up should not exceed the tolerance as well. And if it's not possible to rearrange the matrix minimum of one time, then print -1. Okay, so yeah, so this is the matrix, this is the tolerance, this is the size, and this involves permutation and all. So I already have coded, so let me just maximize this. Okay, so in Python we already have a permutation module, so I just have imported it. For the Java and C++ codes as well, I'll attach in the description, so you can just go through it. So you can see I have declared the matrix n and the tolerance value. Here if you see, the logic that I have wrote is, first I am flattening the matrix. This is called flattening, which is, as we have matrix in the form of this complete in a two-dimensional, I want to keep it in a single list. Okay, like n square elements are there. So like suppose 4 by 4 matrix are given, which consists of 1 to 16 numbers, maybe 1 to 4 will be here, 5 to 8 will be here. So like that it is there, right? So I have to keep 1 to 16 in a single array or single list, that is called all numbers here. That's where I'll get the all numbers list in this number. So once I have this, I'm using the permutation to do the all numbers with the length of the numbers. Then for each numbers, I'll get a sequence, different sequence of permutations here. And for those permutations, I'm constructing a matrix using the again a numpy module. In the numpy module, I'm constructing a np.perm, and here the perm variable I'm taking from the combination, sorry, the permutation of from the module. And for the each arrangement, I'm constructing a two-dimensional array. So this I'm constructing a 2D array for this arrangement. From this 2D arrangement, I'm comparing the valid configuration. So first we have to get the row medium, which we can get from get medium. So get medium we can do array of sort, and we'll return the middle element. Okay, once we have that, we have to make sure the sum of row mediums is less than or equal to p, that is tolerance. And we also will return the minimum of the row medians. So once we have the value, which will be a boolean value, if it's true then fine. And also in the minimum median we'll give the minimum value, that is better. From this minimum median we'll compare the max medium. It's the same logic like how we did in the first question. We'll declare this in the initial, then we'll just compare with the next element and make sure we get the max value. So you got it. So here again, if I repeat it, I'm using a permutation module to get the all the arrangements that are required. Once I have the arrangement, I'm constructing a new arrays. From this array, for each array, sorry, for each matrix, I'm getting a median values, and from those median values I'm making sure that it's not exceeding the tolerance. And also once we have the median values and everything, I'm comparing whether it is the max value of all the set of median values, and finally storing the value here and returning the max min. And also the edge case, if we cannot find the maximum value, which will be, if we cannot, then it will be -1. If it's -1, then just print -1. Okay, let's run this. Yeah, you got 40 as the answer. So this is how we can solve this. It's a little tricky, but if you solve more matrix problems, matrix and permutation combination, it's like a very good combination. So you can try exploring more problems on it. And I'll attach the codes of both the first question, second question in both Python, C++, Java, as requested in the previous videos as well. And in case you want in some other language, uh, then just let me know. Or if you want more clear clarity on the coding on any other language as well, do let me know. Okay, so that's all for today, you guys. All the best.